Om Shri Mahaperiva Sharanam. For the past 3 weeks, we have been discussing questions from Class 9 NCERT Exemplar book from the chapter Surface Areas and Volumes. So today, we'll be concluding this with the last set of questions. Those are long answer type questions. Okay, let's begin. The first question. Rainwater, which falls on a flat rectangular surface of length 6 meters and breadth 4 meters, is transferred into a cylindrical vessel of internal radius 20 centimeters. What will be the height of water in the cylindrical vessel if the rainfall is 1 centimeters? Give your answer to the nearest integer. Take pi equal to 3.14. So, now it says rainwater falls on a flat rectangular surface of length 6 meters and breadth 4 meters and the rainfall is 1 centimeter. So, using the formula volume equals length into breadth into height, we have 6 meters into 4 meters into 1 centimeter. But in order to make all the measurements in centimeters, we have converted 6 meters to 600 centimeters, 4 meters to 400 centimeters. 1 centimeter remains as it is. So, the volume of the rainwater will be 600 into 400 into 1 centimeter cube. Now, the volume of the water in the cylindrical vessel, we know the formula volume equals pi r square h, where r is the radius and h is the height of the water in the cylindrical vessel. That will be equal to pi into r is equal to 20, right? So, pi into 20 square into h centimeter cube. According to the given statement, the volume of the rainwater is equal to volume of water in the cylindrical vessel because it has been transferred into that. So, we have to equate this with this. So, equating that 600 into 400 into 1 will be equal to pi into 20 square into h. So, 20 square is 400. 400 cancel. So, 600 upon pi will be equal to h. And they are asking us to take the value of pi as 3.14. So, substituting that, we get the approximate value of height as 191 centimeters to the nearest integer. So, the height of the water in the cylindrical vessel equals 191 centimeters. Next question. A cylindrical tube opened at both the ends is made of iron sheet which is 2 centimeters thick. If the outer diameter is 16 centimeters and its length is 100 centimeters, find how many cubic centimeters of iron has been used in making the tube. So, how do we do this? Let's say this is the cylindrical tube. This is just for illustration purpose. Now, they say that the iron sheet is 2 centimeters thick. So, that means this, the thickness between the outer tube and the inner tube, that thickness is 2 centimeters. The outer diameter is 16 centimeters. This diameter, the outer diameter is 16 centimeters. And the length, this height is 100 centimeters. Now, the volume of iron used in making the cylindrical tube is the outer volume of the cylindrical tube minus the inner volume of the cylindrical tube. So, that will give us the volume of the iron used in making the cylindrical tube, correct? So, the outer volume minus the inner volume gives us the volume of the iron used in making the cylindrical tube. Now, that comes to pi r1 square h minus pi r2 square h, where r1 is the outer radius of the tube, r2 is the inner radius of the tube and h is the height of the tube. So, taking pi and h common, we have pi h within brackets r1 square minus r2 square. Now, outer diameter is 16 centimeters. So, outer radius r1 will be 16 upon 2 equals 8 centimeters. Now, the thickness is 2 centimeters. So, the inner radius r2 will be this 8 centimeters minus 2 centimeters, that is this inner radius, that will be 6 centimeters. 8 minus 2, 8 minus 2 gives you 6 centimeters. So, pi h into r1 square minus r2 square will be 22 upon 7 into 100 within brackets 8 square minus 6 square. Now, why have we taken 22 upon 7 instead of 3.14? We'll understand it soon. Now this 8 square minus 6 square, either we can do 64 minus 36, which comes to 28. So 7 and 28 will get cancelled. 7 fours are 28. Or we can do this 22 upon 7 into 100. 8 plus 6 into 8 minus 6. A square minus b square equals a plus b into a minus b. So 8 plus 6, that will be equal to 14. 8 minus 6, that will be equal to 2. So this gives you 22 upon 7 into 100 into 14 into 2. 7 2s are 14. So 22 into 100, 2200. Multiplied by 4, 8800. So that gives you 8800 centimeters cube. So the answer will be 8800 centimeter cube of iron has been used in making the cylindrical tube. Next question. A semicircular sheet of metal of diameter 28 centimeters is bent to form an open conical cup. Find the capacity of the cup. Now the question says that a semicircular sheet is bent to form an open conical cup. Let's see. Suppose this is the semicircular sheet, okay? Now how do we form a cone out of it? See how we form a cone? So this diameter is getting folded like this and forming a cone, correct? So now folded means this is getting divided into 2. So half of this is radius, right? So what do we see? Now the radius has become the slant height. The radius has become the slant height. Okay? So now we have the diameter of the semicircular sheet as 28 centimeters. So the radius will be 28 upon 2, 14 centimeters. That becomes the slant height of the cone. Slant height of the cone is 14 centimeters. Now the circumference of the base of the cone is nothing but the length of the semicircular arc of the sheet. So taking the radius of the cone as capital R and the radius of the semicircular sheet as R, we have 2 pi into capital R equals pi into small r. So we have 2 pi into capital R equals pi into small r. Pi gets cancelled. So 2 into capital R equals small r. Or capital R equals small r upon 2, which means that is 14 upon 2, which is 7 centimeters. So the radius of the cone is 7 centimeters. Now to find the capacity of the cup, we have to find the volume of the cup, and to find the volume of the cup, we need to find the height of the cone, correct? Now the height of the cone we know, that is square root of L square minus capital R square. With the given measurements, we have that to be equal to square root of 14 square minus 7 square, and that comes to be approximately 12.1243 centimeters. That is approximately 12.12 centimeters. Now the volume, that is the capacity of the conical cup, we know equals 1 upon 3 pi r square h. So substituting the values we have, now if we substitute the value of h as 12.1243, we get this value approximately 622.38 centimeter cube. Whereas if you substitute 12.12, we get the volume as approximately 622.16 centimeters cube. So to the nearest integer, it will be 622 centimeter cube. That is the capacity of the cup. Next question. A cloth having an area of 165 meters square is shaped into the form of a conical tent of radius 5 meters. First question. How many students can sit in the tent if a student on an average occupies 5 upon 7 meters square on the ground? Second part of the question. Find the volume of the cone. So how do we do this? Now, the radius of the base of the conical tent is 5 meters. So the area of the base will be pi r square, that is 22/7 into 5 square meter square. Area occupied by each student is 5/7 meter square. So the number of students who can sit in the tent will be the area of the base of the tent divided by area occupied by each student. And how much does that come to? So we have 22/7 into 5 meter square divided by 5/7 meter square. Meter square gets cancelled. And working it out, we have 22/7 into 5 into 7/5. So 5 gets cancelled, 7 gets cancelled, 22 into 5, that is 110. So 110 students can sit in the tent. Let's go to the second part of the question. Now the area of the cloth forming the conical tent is 165 meters square. That implies that the curved surface area of the conical tent, that is pi RL, that will be equal to 165 meters square. So we have the radius of the tent equals 5 meters. So substituting that value, we have pi into 5 into L equals 165. So L will be equal to 165/5 divided by pi, that is into 7/22. Now 11 2s are 22, 11 15s are 165, 5 3s are 15. This is equal to 21/2, that is equal to 10.5 meters. Okay. Now the height of the conical tent will be square root of L square minus R square. So substituting the values, we have that to be approximately 9.23 meters. Therefore volume of the conical tent, which is equal to 1/3 pi r square h, which we substitute the given values, we get it as approximately 241.7 meter cube. Therefore the volume of the cone is approximately 241.7 meter cube. Next question. The water for a factory is stored in a hemispherical tank whose internal diameter is 14 meters. The tank contains 50 kiloliters of water. Water is pumped into the tank to fill to its capacity. Calculate the volume of water pumped into the tank. Now, what do we do first is find the total capacity of the tank. And from that, we subtract the amount of water, the volume of water the tank already contains. This gives us the volume of the water pumped into the tank. Now how do we work it out? The internal diameter of the hemispherical tank is 14 meters. Therefore the internal radius will be half of that, 7 meters. So the volume of the tank, this is in the form of a hemisphere, right? So the volume of the tank will be 2/3 pi r cube. Substituting the given values, we have that to be approximately 718.67 meter cube. Now, the volume of the water in the hemispherical tank is 50 kiloliters, that it already contains. That is 50,000 liters, and we know 1 meter cube equals 1000 liters. So, converting it into meter cube, we have 50 meter cube. Therefore, the volume of water pumped into the tank will be the total volume of the tank minus the volume of water already in the tank. So that is 718.67 meter cube minus 50 meter cube. That gives us 668.67 meter cube. Okay. So the answer is the volume of water pumped into the tank equals 668.67 meter cube. Next question. The volumes of two spheres are in the ratio 64:27. Find the ratio of their surface areas. Now, let the radii of the two spheres be R1 and R2 and let their volumes be V1 and V2 respectively. According to the given question, the ratio of their volumes V1/V2 is equal to 64/27, which means 4/3 pi R1 cube upon 4/3 pi R2 cube will be 64/27, which means when we cancel off this 4/3 pi, we have R1/R2 the whole cube equals 64/27. Now, R1/R2 the whole cube equals 64/27 implies R1/R2 the whole cube is 4/3 whole cube, because 4 cube is 64 and 3 cube is 27. So, we have R1/R2 equals 4/3, taking the cube root, positive cube root of both the sides. Now, R1/R2 is equal to 4/3. Let the surface areas of the two spheres be S1 and S2 respectively. So S1 upon S2, we know the formula for surface area, 4 pi r square. So S1 upon S2 will be equal to 4 pi r1 square upon 4 pi r2 square. So 4 pi gets cancelled, r1 upon r2 the whole square, which gives us 4 upon 3 whole square, which is equal to 16 upon 9. So S1 is to S2 is equal to 16 is to 9. So the ratio of the surface areas of the two spheres equals 16 is to 9. Next question. A cube of side 4 centimeters contains a sphere touching its sides. Find the volume of the gap in between. Now it says that the cube contains a sphere touching its sides. So if the sphere is touching the sides, that means the diameter of the sphere will be equal to the side length of the cube. So if the side length of the cube is given to be 4 centimeters, the diameter of the sphere will be 4 centimeters. So the radius of the sphere will be half of that, that is 2 centimeters. So the volume of the gap in between the cube and sphere will be the volume of the cube minus the volume of the sphere inside. And we know the formula. Volume of the cube equals side cube. Volume of the sphere equals 4 upon 3 pi r cube. So substituting the values, this is 4 cube, this is 4 upon 3 pi 2 cube. We have the volume of the gap as approximately 30.48 centimeter cube. So the volume of the gap in between the cube and the sphere is approximately 30.48 centimeter cube. The next question. A sphere and a right circular cylinder of the same radius have equal volumes. By what percentage does the diameter of the cylinder exceed its height? Now they have given that the sphere and the right circular cylinder have the same radius and the same volume. So let the radius of the sphere be r. Therefore radius of the right circular cylinder also will be equal to r. Also according to the question, the volume of the cylinder is equal to the volume of the sphere, which means pi r square h will be equal to 4 upon 3 pi r cube. So h will be equal to 4 upon 3 r. Now h is equal to 4 upon 3 r. The diameter of the cylinder is 2 r. So the difference in length between the diameter and the height of the cylinder is 2 r minus 4 upon 3 r, which is equal to 2 by 3 r. Therefore, the percentage excess of diameter with respect to height is the difference in length between the diameter and height of the cylinder upon height of the cylinder multiplied by 100. That is 2 upon 3r divided by 4 upon 3r into 100, which gives us half into 100, that is 50%. So the diameter of the cylinder exceeds its height by 50%. That's the answer. Next question. 30 circular plates, each of radius 14 centimeters and thickness 3 centimeters, are placed one above the other to form a cylindrical solid. Find first the total surface area, second the volume of the cylinder so formed. How do we do that? Now 30 circular plates, each of radius 14 centimeters and thickness 3 centimeters, are placed one above the other to form a cylindrical solid. Now the radius of each circular plate is 14 centimeters and the thickness of each circular plate is 3 centimeters. So if thickness of each plate is 3 centimeters, the thickness of 30 such plates will be 30 into 3, 90 centimeters overall. As 30 circular plates are placed one above the other to form a cylindrical solid, the height of the cylinder will be the thickness of the 30 circular plates, which is 30 into 3, this height is 30 into 3, 90 centimeters. So for the first question, we have to find out the total surface area of the cylindrical solid. Now we know the TSA of the cylindrical solid is 2 pi r into h plus r. Substituting the values, we have 2 into 22 upon 7 into 14 within brackets, height is 90 centimeters, radius is 14, right? So substituting those values, we have 2 into 22 upon 7 into 14 within brackets 90 plus 14. That is, these two gets cancelled, 22 into 4, 88 into 104. that gives you 9152 centimeters square. So the answer is the total surface area of the cylindrical solid so formed is 9152 centimeters square. Now let's go to the second question. The volume of the cylinder so formed will be, we know the formula, pi r square h. So 22 upon 7 into 14 into 14 into 90. So 7 2s are 14. Calculating this, we get the answer as 55,440 centimeters cube. So the answer is the volume of the cylinder so formed is 55,440 centimeter cube. Now with this, we have finished the long answer type questions also. In the next class, we will discuss another topic. Till then, Om Shri Mahaperiva Sharanam.